All right, section 9.7, factoring special cases. I actually don't like that there's a separate section for special cases because really it's still just factoring. But before I jump into example 1, I want to talk a little bit about when you might notice ahead of time and just make life a little bit easier. So let's say we have something like 4x squared plus 12x plus 9. We'll look at this one, and then at the same time we'll look at another one that looks like this. 4x squared plus 20x plus 9. So hopefully you see right away that really the only difference is this middle term. Everything else is the same. They're all positive. They all have x squared. There's a 4x squared. There's a 9 at the end. It's the middle term that's different. So what we can pay attention to then to make this just a little bit more efficient, this, and when you're looking at the whole box idea, would fit into here, 4x squared. And this is the case for both sides, the purple and the teal. And 9 would go here. So really your only options for this upper left box would be 2x and 2x. You could have a 1x and a 4x. We're going to stick with that for now. And conveniently, your options really for 9, you only have the options of 1 and 9 or 3 and 3. Let's just go with 3 and 3 for the moment. If I do that, so if I'm looking up at the top part, more of a horizontal method of looking, I have 2x and 2x as my factors. And if I change color slightly to for the 9, that would be 3 and 3. And then so that's where this 3 and this 3 are. So the kind of cool part is here's my 3 and here's my 3 and here's my 2x times and 2x times. There are 2 of them right here. This middle term is 2 times each of those factors that were involved. The 3, oops, I put that in the wrong spot, the color wise. 3 and the 2x. So I used one of these factors, whoops, and I used one of these factors here. And let's see what that equals. Well, 2 times 2 is 4, times 3 is 12, times the x. So I have 12x. Happens to be right there. This one has the same thing on both sides. So the factored form would be 2x plus 3 times 2x plus 3. And that can be rewritten more simply as 2x plus 3 all squared because it's the same factor times the same factor. Let's see if that's the case over here with the 4x. So it's the same box, so I'm going to kind of go a little quickly with this. This still has the factors of 2x and 2x, and still the factors of 3 and 3 here. But does it hold true that I need it double? Do I need double of one of these factors and one of these factors? So let me fill in my bubbles with the black and then do color coding so you can follow where I'm going with this. Take one of these factors and one of these identical factors. Do I get this middle term? Well, this does not equal 20x. We just saw over here that it equals 12x. So this one is not what's called a perfect square trinomial. There's just a special name for it. And I'm going to come back. Your book has it in an order that I want to reverse a little bit. I want to take a look at example 1, and then I'll go back to what your book has as the orange box. Okay, so let's take a look at example 1. So it says to factor x squared minus 8x plus 16. And as I keep going back to this, I'm going to go back to the box. It helps us keep things organized, make sure we always have what we need to have, pays attention to signs. You'll get used to not using it at some point, but for now we're going to keep it. 16. So pretty simply, x squared can only be broken down into x and x on the sides. X times x is x squared. 16 has some options though. 16 could be 1 and 16, 2 and 8, 4 and 4. Those are all of my options. I'm noticing right away that I need 8 in the middle. Well, if I have a 1 and a 1, I'm not too worried about what those are going to do to these x sections, the middle term part, right? How they relate to that. So I won't worry about the value here affecting it. So I'm just going to look at what happens when I then add those terms. That would give me 17. And if this is positive, I know they both need to be a negative and a negative because that middle term is negative. So it would be a negative 17, or this would be a negative 10. Well, I'm not getting to the negative 8. These, if they're both negative, would be a negative 8. So I'm going to use negative 4 and negative 4. And just to double check my work, I would say that this is negative 4x, and this also is negative 4x. These two are identical. So, as are the factors then. So we can write this factor as x minus 4 times x minus 4. And again, if it is this, you do need to write it as simply as possible, meaning x minus 4 all squared. That would be your simplest form and factored form of this original trinomial, okay? So hopefully not too difficult. The orange box that your book shows right before this is called perfect square trinomials. It's just the pattern. Perfect square trinomials for every real number, a and b. This is going to be true. If I have a squared plus 2 times ab, in other words, whatever is the square root of a squared, right there, and then add to it b squared, so whatever the square root of b squared is, there's the factor of it. You can then factor this to be a plus b times a plus b. And again, more simply written, it would be a plus b all squared. You have 2 factors that are identical. It works the same. Let me change the color actually, just kind of for the fun of it. A squared minus 2ab plus b squared. It's the same sort of thing. The only difference is going to be the sign of b in your bubbles. You'd have a minus b, because this negative b times negative b is going to give you the positive b that you need, as well as the negative doubling of the a times b in the middle. So then, again, simplified, this would be a minus b all squared. I know I'm going kind of fast. I am because I don't particularly care about memorizing this stuff. It can be helpful, but more than anything, if you have a strategy to solve and to simplify, to factor, there we go, to factor, if you've got a strategy to factor, you don't need to remember these things. It might be helpful to recognize it, and we will come back to this. We will use this later on, but you don't need to memorize this formula to be able to factor like that, okay? Example 2. So if I have a square, that's going to be a square. So ignore that it's not drawn perfectly. The area of the square shown, area is 9g squared plus 12g plus 4 centimeters squared. All of that is measured in centimeters squared. Find an expression for the length of the side. Find length. That's our goal. Well, just like we've been doing all up here, this is super helpful. I can just break up my area into those 4 regions, and I can label those 4 regions with what we know would fit there, where this would be the 9g squared. This would be 4. And then, hey, we're in this section, so you can take a guess what it's going to look like, but I'm still going to run through it. 9, the factors would be 9 and 1, or 3 and 3. The factors of 4 are just 1 and 4, or 2 and 2. We want a middle term of 12. There's going to be some interaction between the factors of 9 here and the factors of 4 here. So we do have to pay attention to how these are paired up to know what they're going to multiply to. So if I'm thinking ahead a little bit, do I want to multiply 1 times 1 and add that to 9 times 4, well, 9 times 4 is 36. That's pretty far off of 12, so I don't think that'll work. And even if I were to switch those to have, let's go back a little bit, pair up 1 times 4, that would be 4, and 9 times 1, that would be 9. I don't want to add those. That would still be too much. It's close. It's 13. But it's still not 12. If I go down here and I pair off, the only way I can pair it, because it doesn't matter, 3 and 2. It doesn't matter which 2. They're both 2. And 3 and 2 have got the same things. I would get that is 6 and that is 6. 6 plus 6 is 12. So those would work. So I can go on my square and say 3y, both those factors, and a positive 2, because I've got a positive and a positive 2. In this box, I would have 2 by 3y, which would give me 6y, and then 2 by 3y would also give me 6y. Those together give me the 12y. So I have my factors. I have my length. Length equals 3y plus 2. Notice it did not ask me for the factored form. It asked me for the length of the side of the square. Pay attention to what's being asked so you actually answer what's being asked, not something you think is being asked. Okay, hopefully so far so good. Let's try, again, I'm going to go the reverse order your book does. I'm going to do example 3. Then I'm going to go back to the orange box idea. So we're going to factor x squared minus 64. There's no middle term. X squared minus 64. Well, let's see, if I used a box, if I have this, I know that I would have the x squared term goes here always, and the other non-x term, the constant term, will have to go here. But there's nothing here. So we have to figure out what might make this still work. So again, it's pretty simple and straightforward in that the x squared can only be x and x. That's simple enough. 64 has a lot of options. I've got 1 in 64. I've got 2 in 32. I've got 4 and 16. And then no 5, no 6, no 7, 8, and 8. 8 times 8 is 64. So all of these multiplied together would give you 64. Each of those, I should say, each pair. So, but I need no middle term. If it helps to see it this way, you could write x squared. That's an ugly squared. X squared plus or minus, I don't care. 0x. There's nothing there. Minus 64. I want the sum of the diagonals, the two that we were looking at here and here. Sum of the diagonals to be must equal 0. Well, this is helpful too. I've got a negative. And the only way to get a negative is to have a positive and a negative factor to give me the negative number there. So if I add or subtract those, I'm only going to get to 63, positive or negative, doesn't matter. I'm only going to get to 30, positive or negative, doesn't matter. It's not 0. If I add those or subtract those, I would only get to 12, not there. But here, if one is positive, one is negative, I get to 0. So I need to use a positive 8 and a negative 8. So that in the green shaded area, I'd have a negative 8x and a positive 8x. Those two now will cancel. So look at your sides of your square. You have what's called difference. I'm going to highlight up here on the original. The difference of two perfect squares. X squared and 64 are both perfect squares. So when you see something written in the form, I'm going to use black, a squared minus b squared. There's the key part there. There's a key part there. There's a key part there. B is a perfect square. A is a perfect square. And there's a subtraction between them. clean it back up though. So if I have that, automatically, you will get to this, but it takes practice. You will get to saying A, like my x, plus B, like my 8, times A, like my x, minus B, like my 8. So if I go back to up where we were, I'm combining a couple things all at the same time. My original problem would be factored as x minus 8, x plus 8. And that's it. So your orange box, I'll rewrite it as a simplified orange box of key concept, right? I haven't done this in a while. Key concept is difference of two squares. In other words, the subtraction of a squared and b squared. Usually, not always, this one's going to be a number, not a variable. So if I do example 4, and I'll leave that right there on the screen. Example 4 is going to get, of course, a little bit more complex than example 3 was. If I have 4x squared minus 121, well, I can still use my box if you don't recognize what the squares are. I'm going to do the box first, and then I'm going to do the quick version of, hey, I recognize that it's two perfect squares. This is what I can do. So here's my box. I know where those things go, and I just have to figure out those two have to add up to 0. So 4x squared, 121, and that's a negative. So right away, it's a negative. I know one thing has to be negative, one thing has to be positive. And the 4x could be broken down into 1 and 4 or 2 and 2. Since we're in this section for the moment, I'm going to assume we're going to go with the 2x and 2x. Okay? The factors of 121. If you don't remember, you do need to grab a calculator. It's actually, this is a relatively easy one, is in that you only have 1 and 121. Not very helpful for getting to 0. And then 11 and 11. It is a perfect square. 11 times 11 is 121. So if I have a negative 11 and a positive 11, you would have 22x here and negative 22x here, which again, conveniently, those cancel and drop out. So the factored form of this would be that and that written out is 2x minus 11 times 2x plus 11. And that's it. It is following the difference of two squares, where I didn't finish writing that out. I apologize. A squared minus b squared equals a minus b times a plus b, right? Where you want to take the square root of a squared, whatever that is, and the square root of b squared, which is what gets plopped in there and in there for those two. And then if I take another starker color, the a squared gets plopped in there, or the square root of a squared in there. And you just then have the minus and the plus. They will always follow that pattern when you have a perfect square taking away a perfect square, right? Okay, last example. We'll stick with this color, sure. Example 5. So it's not simply this one up here. There's a slightly bigger thing going on here. So if I need to factor completely, I'm adding the completely part. Your book does not have that, but I think it helps when it's there. It gives you a hint. If I have 10x squared minus 40, well, 10 is not a perfect square and 40 is not a perfect square. So there's not a third term. So if I just go straight into filling in my box, 10x squared and negative 40, I'm going to run into an issue of 10 only has factors of 1 and 10, 2 and 5, and that's it. And then 40 only has factors of 1, 40, 2, 20, 4, 10, and 5, 8. You can work, I'm going to give you the hint and time saver of none of these pairs anywhere in here. If you pair off these two and these two, that's not going to add up to 0. These two, that'd be 40 and 10, that's not going to add up to 0. You could take this one and here, 4 and 5, that'd be 20. and that would be 20. Those actually might work. Maybe you can factor this one otherwise. Yes, you can. But you wouldn't have it factored completely. I'll do this actually right now. So if I have a 5x, because I saw that those are 20, and then the 2 and the 10 are 20. So I would need a 2x here. And that means the 2 needs to multiply the 10, so that 10 would need to be here, so that this would be 2x times 10 to give me 20x. And 5x needed to multiply down here 4, so this would have to be 4 here. And that would be 4 times 5x right there, which would be 20x. And they need to be opposites because that's also negative. So I don't think it really necessarily matters here which one. I can put the negative here and the positive here. It doesn't matter. But I'm not factored completely here if this is the case. So if I look at this and I say, okay, I'm going to factor it, I get 5x minus 10, and I get 2x plus 4. If I look closely at these, let's see something here. This 5 and this 10 have a factor in common, so it's not completely factored. This 2 and 4 have a factor in common. It's not completely factored. You need to take those common factors out. So let me take kind of let's see, this has a factor, they both have a factor of 2 that needs to come out, and then these both have a factor of 5 that needs to come out. So I could say 5 times x minus 2. This is a very complex way of doing it. And then I'll go back into the easier way. And then this one needs a factor of 2 taken out. And since it's all multiplying, I'm throwing parentheses around that too. X plus 2. Okay, well that's super messy too. But I have a constant, and multiplication we can do in any order. So if I rearrange it to be 5 times 2 times x minus 2 times x, plus 2, wait a minute. This should hopefully start to look a little familiar. X minus 2, x plus 2. But this little thing going on out here shouldn't be left as that. You can do a number times a number. So my final answer with all this cleaned up would be 10 times x minus 2, x plus 2. That is factored completely. If you didn't see what I'm about to show you first, you can still get to the final answer. It's just a lot more difficult. If at the same time you noticed in the beginning up here, I'm going to rewrite it down here to just start over because this is convoluted and crazy. If I have 10x squared minus 40, please see right away 10 and 40 have a common factor. Always try to factor out any common factors first. The GCF is 10. Both terms can be divided by 10. So I need to factor out the 10. So I can say it equals 10 times x squared minus 4. Now it should look super simple. This x squared minus 4 is the difference of two squares. And this time I can quickly, I'm just going to show it up here, the box. And I'm just looking at the parentheses portion. Negative 4 and x squared. So I have to have an x. I have a negative 4 down here. The only way to really factor that and have these disappear would be have a negative 2 and a positive 2. Not 2x. I've seen some kids do that. Just the 2. So there's my factors. So those two sides need to replace this parentheses while keeping the 10 there. So the 10 stays. That's a factor. And then I've got the factor of x plus 2 times x minus 2. Hopefully, at some point, you guys have noticed that I did x minus 2 here, but x minus 2 in the front here. And I did x plus 2 here and x plus 2 here. And I'm hoping, as I can't really ask you a question and get an answer back, I'm hoping you notice it doesn't matter which order you do it in. For the same reason that 3 times 5 equals 15, as does 5 times 3 equals 15. Order of multiplication does not matter. The order inside there would. You would not want to say negative 2 plus x or negative 2 minus x or x 2 minus x, I should say. Keep that inside stuff the same. Okay, hopefully this has all made sense. I'm going to throw several try these up here. I'm done teaching for the lesson, but I'm going to throw try these up here, and you can work them out, pause it after you're done writing them, and then check your work. Okay, so 4t squared plus 36t plus 81, and then b will be m squared minus 100, and c will be 3c squared minus 75. And d is n squared minus 16n plus 64. So if I go, pause it, and then go ahead and work these out. You do need to have it written as simple as possible, being 2t plus 9 all squared. Don't forget the 3 is still there out front. It didn't just disappear. I'm going to point out this is negative, which means here and here I have to have opposite signs, a plus and a minus. Oh, I did the same thing. I screwed that up. Sorry. You have to have a, of course. Sorry, minus and a minus because it's minus there. This needs to be a minus so that you get a plus there. Sorry, I'm trying to go too quick. See, I'm not even following my own advice. So I need to use an 8 and an 8. I have negative 8n and negative 8n. Together, that would give me my negative 16n. So my factored form, n minus 8 times n minus 8. And it is the same, so I need to rewrite it as n minus 8 quantity squared. And that's it. Hopefully, this has all made sense. I'm going to put a quick box around each of my final answers so you can hopefully check them quickly. I guess I'm highlighting that one. Okay. All right, contact me with any questions. Thanks for joining me.